If you clicked on this video, you are probably tired of watching some XSS videos showing a simple attack payload that works on a very old PHP application, but when you try to apply this in a real bug bounty program, your payload never triggers. The truth is that this kind of exploitation was really popular back in the day, but now seems that even the simplest application have great security against cross-site script. So in this video, I'll be showing you how modern web applications handles XSS and how to find it. For those who don't know me, my name is Marco, I'm a software engineer and a cybersecurity enthusiast, and the main technology I work is primarily with web technologies. So, to understand how a cross-site script works, I created a really simple PHP script here that is basically a reflected cross-site scripting. As you can see, my code here gets the query parameter name and reflects it in the screen. So if I access here it in my server, name equal Marco. As you can see, the code is reflecting my name here. Hello, Marco. The problem is that this code is not doing any sanitization, and PHP does not sanitize anything by default. This means that if an attacker appends a script tag here, alert1 script, the script will be executed in the screen. So back in the day, how a developer secure his application against this kind of attack? I have another script here I called fixed.php. Basically, it's the same script, but I added this line here that sanitizes the string I'm sending using a built-in functionality of PHP called HTML special shares. So if I access here my fixed.php with the same name in my script, as you can see, now my alert tag is being sanitized. So this is how a XSS attack works. To understand how modern web applications deals with this kind of attack, we need to understand how developers are writing web applications nowadays. With my experience, I can say 100% sure that the most used web developer framework that people are using nowadays is React. React is a JavaScript framework developed by Meta, Facebook back in the days, but you don't have to believe what I'm saying. You can confirm that by using some extension, for example, Wapalizer, and take a look. For example, GitHub uses React as a framework, Airbnb also uses React as a framework, Apple are also using React as a developer framework. So how React handles this kind of attack? So I created this other proof of concept here. This one is using React in the latest version. Basically, it does the same thing that my other page was doing, gets my name parameter and reflects it in my screen. So here's how a React application code works. It's essentially the same of the PHP application that I showed before. I'm getting my query parameters here and reflect it in the screen inside the h1 tag. So let's see what happens when I try to execute the same attack that I executed before here in my React application. As you can see, my payload won't trigger, and if you see here in the web developer tools, by default React sanitizes this kind of attack for me. This is the point here. This means that even the junior developer in his first job as a software engineer is probably writing code that's secure enough against this simple attack, because React has a built-in functionality that sanitizes any payload that's showing the screen for the developer. So this is how a normal React code works. But you may be thinking, this means that React is not vulnerable at all to cross-site scripting? And the answer is obviously no. But in order to a developer appends JavaScript code here, it needs to do some kind of different work. Let me refactor this code in order to it be vulnerable to this kind of attack. So I recreated here the same HTML page, but this time it will be vulnerable to my attack. Pay attention that in order to the application be vulnerable, the developer needs to use a prop called dangerously set inner HTML tag. And the name of this prop is self-explaining. It's telling the developer that this is a dangerous functionality. And if we try here, script alert1, we can see that now, even though my script tag is being appended in my DOM, in my document, my alert function is not triggering. Even when the developer is using a tag that's clearly saying that it's dangerous, React is also protecting him against this kind of attack. In order to my attack work, I need to do another payload, for example, an image *sex on error alert1. I'm closing my image tag here. Now, as you can see, my alert is popping up. But what new hackers may be thinking here is that no, now I understand, this is the magical payload I need to use when I'm testing for React applications. But that's not the point here. The point here is that cross-site scripting on React applications Depends on context, because as our normal use of a React parameter and variable, any variable may be already sanitized. So what I'm trying to say when I say that it depends on context, so taking me as an example, a thing that I did a lot when I started bug bounty was when I faced this kind of situation here, I saw that text was reflecting on the screen, I saw that it was being sanitized, I knew it was a React application, but I spent hours and hours trying to bypass the sanitization. And the truth is that Meta did a great job while securing this feature. It's maybe not worth it trying to bypass it and move on. So if during your hacking you identify that the application is using React and the variables here is being filtered correctly, take a look into more juicy places that you can exploit it. What I say about context, taking here a public VDP for example, when building a React bundle to production, some people even enabled a feature called source map. What a source map is, basically it shows to anyone that can access the page an unmodified code of the application. You can completely see how the developers actually write the code here of this application. So don't take me wrong, this by itself, it's not a vulnerability, so don't report it in any bug bounty program. So you can use it as a tool while doing your pen test, for example, taking a look, the dangerous set in your HTML tag prop here, and take a look whether the developer used this kind of props that set it dangerous. Now you can focus more, and don't get me wrong again, just by using dangerous set in HTML doesn't mean that the application is vulnerable. You need to try yourself, take a look if it can exploit this variable that is being used, because sometimes you won't have control over the variable that is being passed here for the HTML. And another great example here that I can show you is a vulnerability that I found in a real bug bounty program that awarded me a bounty of $600. As you can see, this is a much simpler version of the code that was vulnerable, but it's essentially the same vulnerability. The application is getting a referral from the query parameters of my URL, and when clicked on the button redeem referral, it sends a script in the page that do some kind of tracking from the user that executed this referral. So let's see how it works in reality. I put here my referral marker 123. When I click on redeem referral, it appends a script tag with the referral marker 123 here. Let me try to exploit it here. For example, I'm sending a marker 123, a single quote. This is a plus sign URL encoded, alert 1, another plus sign, and I'm opening another string here, another single quotes. So let me refresh my page, and now if I click in redeem referral, as you can see, my alert triggered. This happens because in this case the developer was not using the dangerous set inner HTML tag, but actually using the built-in JavaScript function called inner HTML that basically works exactly the same way that the dangerous set inner HTML function works. In summary, what makes people think that web applications are not vulnerable to XSS nowadays? It's because the modern frameworks is already providing great security against this kind of attack built into the application, and the developer doesn't even need to know what an XSS attack works, but he still is pushing code that is secure enough against this kind of attack. And the key point here is to look for context, try to understand where may be vulnerable. Don't take too much time trying to bypass a sanitization when you see that the application is using React, and maybe move on. And that's it. I hope I helped you to learn something new and to understand how modern web applications are being developed and how to find cross-site scripting in these modern web applications, and leave comments, ideas for me for vulnerabilities that I want to learn from a web developer perspective, and see ya.